Hello everyone. I did a study to predict heart attacks before they happen. I want to tell you about the code I wrote. First of all, we need to know the dataset we have and how we should classify this dataset. My task is to find the best classification model and show our process. I am adding 4 classification algorithms in the scikit-learn library. These are KNN, decision tree, logistic regression, and random forest classification. Then we use matplotlib to visualize our data. SciPy, Pandas, NumPy, and Seaborn libraries perform operation on the data. The second part is the reading our data. We read our CSV file with the methods in the Pandas library and get information about our data. You can see a total 14 variables and their data types. To better understand the names on these links, you can go to the link I left in the description. We have read the data, but we need to check if there is any duplicate data in them. As a result, there is one duplicate line and we delete it with drop duplicates method. After there is no duplicate data, we check if the unique variables also have null data. As can be seen here, there is no empty data in our variables such as gender and age. But we still need to check if there is outliner data using the interquartile range. Otherwise, lower than expected efficiencies will be obtained when training our model. The following figure shows the range of each variable. We have an upper limit and lower limit in the quarterly gap formula. We apply the quarterly span formula of the data1 variable and see our values as output. We observe that the gap is low, the differences between our values is not much, that is, our data set is suitable for classification. Then if z-score is greater than 3, it implies that the data points differs from the other data points and hence is treated as an outlier. Now it is time to correlate our data. Why do we correlate? Because we can see which of our variables are in harmony with each other, and it would be more efficient to calculate them. There are two types of correlations here. One of them is Pearson and the other is Spearman. Pearson also examines the linear relationship between two continuous variables, while Spearman evaluates the monotonic relationship. The outstanding data in the Pearson correlations are tillage and output values with the value of 0.43, SLP and outpeak values with the value of minus 0.55. The same values appear to be duplicated in this heat map. We can solve this problem by mass, and in our second map, our data looks more accurate. Now we start the estimation process by classification our data. First, we separate our variables to be tested and trained. Here we will use 70% of our data as train and rest as a test. The first algorithm I will use is logistic regression classification. I determine the titles that I will use here, and then I start the learning process, that is the fit process. I am showing the efficiency of our model. With an efficiency of 83% extra, I remove the smallest negative values in correlation from my dataset and try again. The part we need to pay attention to here is that these subtractions should be removed from both test and train variables. And the result is almost the same. There is a similarity in efficiency. Next is the decision tree algorithm. I set up a tree structure with a maximum weight of 6 and created without specifying any random state. Then I started training my model and printed out my normal productivity and my productivity with variables removed. Here my efficiency 80% and 82%. This model also worked, removing data that didn't fit the correlation. There is another algorithm, the random forest classification. Here, after similar operations, we measure our efficiency 85%, unlike the previous one. Here, I extract each feature one by one, find the score of the feature and subtract the lower one. Then I am using KNN classification in our final algorithm. Here, our efficiency is 74%. As a result, our best performing model to predict heart attacks is a random forest classification. Source code and viewing link are in the description. Thanks for watching.